coming to you live from the Intel Developer Forum in San Francisco. Stay tuned for Das Kamhaut, coming up next.
Welcome to Chip Chat. We're coming to you live from the Intel Developer Forum in San Francisco. I'm Allison Klein, and I'd like to introduce my guest, Das Kamhaut, Cloud Orchestration Architect and Principal Engineer at Intel.
Hi, Allison. Thanks for having me.
So tell me if I even got your title correct that time.
Yeah, that's pretty close. I changed my job about 5 months ago, but I used to, actually I knew you before when I used to run all of Intel IT's grid environments and private cloud, but yeah, Cloud Orchestration Architect sounds fine.
Awesome. So you brought some friends along with you for this interview. Do you want to introduce them?
Yeah, so I have John Wilkes here, who's a Principal Software Engineer at Google, and I have Scott Carlson from PayPal, who works on their infrastructure.
So I know you guys are doing a talk, and welcome. I know you guys are doing a talk together today on Can the Data Center Think for Itself? You guys run two of the most advanced data centers in the world from a collective perspective. Can you talk a little bit about what you do at your respective companies and what the overall challenge of what you're taking on ties in with your company's business?
Sure. Scott Carlson here. I am an architect at PayPal. We are part of eBay. Up until recently, I was the lead architect for our compute environment at PayPal, where we worked on scaling hyperscale compute up to service our payment customers. Recently, I've moved into the security space where I'm focused on security architecture of our cloud, security of our payment engine, and trying to figure out how we can take all of these new technologies, secure them, and still run, one of the most secure payment engines on it.
And John?
Hi, John Wilkes. Thanks. Good to meet you. So I'm part of what we call technical infrastructure. We're the people that provide the software that everything else inside Google runs on top of. What I like to say to people is, if you can see what I've done, it's gone horribly wrong.
Very nice. So Intel has been talking about software-defined infrastructure. Other people call it software-defined data centers. DOS likes to remind me that while this is a vision for some, this is a very big reality for others. Can you guys define what that means for your companies and what it allows you to do?
So we got into this game by starting by purchasing really cheap, rather flaky hardware. And what we discovered that by putting a layer of software on top, you could get really very reliable systems that could scale up with remarkably few people required to manage them. And that seemed like a good direction to go, so we've been continuing to go down that path. So you could say we have an extremely competent platform team that builds really very nice hardware, but the secret sauce is in how do you glue all of those things together with software to get the kind of effectiveness that you want at a large scale with super high reliability.
At PayPal, we have a problem with scaling up to meet demands of our holiday season. And so every year in the United States, people are familiar with Cyber Monday and Black Friday and all those sort of really high-volume payment days. And in the past, we would have to start months and months and months in advance so that we could scale up to meet these payment volumes, build lots of servers, deploy lots of virtualization. And when we would take a look at, how much more CPU I need, how much more memory I need, it made a lot of sense, especially in the automation area, to go from how densely can I pack my physical gear, more than hyperscale in many cases, to how can I automate VMs, physical deployment, and then how can I build payments in a box on top of all this compute that I've automated across my data center. So the problem I'm trying to solve is, how do I do that securely? How do I scale everything up to meet the demands sort of real-time-ish?
Thus, I know in your previous job you spent some time building out this type of capability into Intel's data center. When you look at what some of the large-scale data centers have been able to do and the divide between that and where traditional enterprise is today, what are the key attributes that are the transition points, and what kind of technologies need to be developed to bring everybody up to where this is going?
Yeah, there's actually a combination of things. So there's technology, there's mentality, the philosophy, and those actually go kind of hand in hand. So in my past job, I was fortunate enough to live in a grid computing world where, John talked about this earlier today. If you have, tens of thousands of nodes, you should expect some to fail. But that's not a normal concept for a lot of people. And when I switched into the private cloud space, like in our traditional IT, I wanted everybody to understand, hey, we could actually have a data center fail, and I'd prefer you don't get called. So that's like a basic mentality concept of how much infrastructure. Well, I mean, obviously your data center takes up 60% of your capacity. You don't want it all to go away. But just the basic mentality of understanding things do fail. They always will. You should assume that. That's kind of the philosophical perspective. And that leads into the technology and the choices that you make on patterns. The nice thing that we're seeing today on the technology side is the open source movement is moving quickly. While there are proprietary solutions too that are stepping into this environment, I think Linux really created the core that allowed people to scale on top of that. So now we're seeing a pretty large movement on top of Linux. If you think of Linux as like the piece that made the host work, now we're starting to see the pieces that make the entire data center work. And this is, for instance, orchestration solutions like what we see with OpenStack, with Mesos, with Kubernetes. These are all solutions that are going into the open community to basically say, hey, this philosophy, this mentality can change. Here's some technology. We can all get together, code together, and push this forward. And obviously, since I work at Intel, part of what I care about is making sure that as we progress forward with our silicon, that it's giving out the right information and able to take the right actions to basically help everybody optimize in their infrastructures, because they're going to have more and more problems as they scale. So yeah, mentality, philosophy, and a combination of tech that's happening today.
John, you talked about the scale that you guys are operating at, and obviously your solutions are fully automated to get to the levels of efficiency of management oversight. I've also heard you guys talk about the fact that you build that automation with a way to actually have intelligence to make better decisions over time. Can you talk a little bit about that?
Sure. So let me actually echo something that Scott said earlier today, which was people need to trust the systems you're building, because otherwise they won't come to rely on them. And if they don't come to rely on them, they will do things manually, which means they will make mistakes. So if you can build and demonstrate that the systems you're constructing are incredibly reliable and always stay up and make good decisions all of the time, then what you will find is that people will say, I don't need to worry about that kind of stuff. I can let go of concerning myself with. I can get back to focusing on what I should be focusing on, which is adding value on top of the systems that we're constructing here. But the way that works is you have to be continuously running behind the scenes to keep the system maintaining that degree of trust in its users, right? You have to be coping with hardware changes, with flux in the way we configure systems, alterations in the way we do networking, changing expectations about what people want. You have to be monitoring it continuously. We believe strongly that you have to be very transparent about what that monitoring is telling you. Your customers have to see what is going on behind the scenes so they can go, yeah, I get it. You have to explain, and we have a very strong culture of if something does go horribly wrong, we will do a blame-free post-mortem. We're interested in trying to find out what went wrong so we can work out how to not make the same mistake in the future. If you do these right, what you end up with is discovering that engineers will actually compete to be people recording, no, I screwed up worse than you did. Let me contribute to the understanding what's going on behind the system. All this is part of a sort of continuous feedback loop for keeping the whole system at the Uber level moving in the direction you want it to be working on. So you have to be concerned both at the personal and the sociological level as well as the technical stuff.
It sounds like a philosophy of understanding that nodes will fail can kind of also transcend into the philosophy that people sometimes fail, and that's an okay thing too.
Absolutely, yes.
No, Scott, you talked about the importance of security in all of these solutions, and we can talk about failure all we want, but we can't have security fail to the point that it has an impact on your customer. And I'm so happy because I am an avid user of PayPal that you're worried about this. Can you tell me a little bit about how you approach that, and what are the critical technologies in place to ensure that you've got some trust in that solution?
Well, if you take a look at how PayPal sort of philosophically looks at infrastructure, it's customer first always. I mean, we're touching people's monies. They trust us to have that payment get done right and when they click the button. And so as we analyze both the applications that come in and the hardware we come in, it's all about, is the money safe flowing through here? And are all the tools that I use capable of actually looking at these systems to decide if they really are safe? If we look at open source things, we really have to think, has anybody else ever used this in a PCI-compliant way.
Right.
If not, then I guess we have to do the extra analysis. We have to look at the code. We have to use some of the tools that other people have written, do a code analysis, do a compile analysis, do all these things, bring in people together to look at, okay, can we really trust this? Is it safe? On the third-party side and the cloud side, you can look at those products and technologies and say, is anybody else doing this? Have they, gone through the things that are in standard? Have they done the tests, right? Has anybody ever done a hackathon on product X where they've thrown the best of the best at this to prove that it actually holds up under a real-world scenario? A lot of these things work great in the lab.
Right.
A lot of these things work great on low scale. But when you put millions and billions of people or dollars underneath it, the game changes. And with all of this compute, all of these engines, all of this other thing, no matter what tool we pick, right, because we have them all probably, you have to look at, does it work in a tiny use case? Does it scale up to the gargantuan use case? And does it break in the right way? And I think from a security perspective, your site going away is as big of a security problem as things disappearing or people getting in. And denial of service attacks, how we protect against that with scale up, scale down, and some of the new protections coming on the hardware are all things to be considered as we look to protect how the money flows.
You guys are obviously, out in advance of technology adoption, but even you guys, I know, because to keep that position, are thinking about what's next. So John, I'll start with you. When you take a look at what you can't do today, and you're seeing technology here at the Intel Developer Forum, I know that you guys are talking to industry players all the time. What's the next thing that you're excited about?
I'd be hard-pressed to pick a single one. So I think two general trends I see. The first is the trickle-down of the kind of capabilities that you see at, frankly, the lunatic fringe organizations like us. Having those capabilities be made accessible to lots more people in the world, both in terms of developed Western environment, but also looking at a much broader range of people in the developing world. Joel Birnbaum once used to talk about a thing he called ubiquitous computing, which you notice by its absence. We see more and more ability to make those kinds of things available to people all across the world. That to me is incredibly exciting. Yes, there's some fun technical things that are happening behind the scenes. Great, but those are almost secondary by comparison to making available the kind of things that we've got used to a much larger range of population and people.
How about you, Scott? Anything in particular come to mind?
Yeah, I believe there's two, from my own opinion here, two really important things that we could use help on, and everybody could use help on. One of them is the authentication of the human being, right? People have talked about getting rid of passwords, device authentication, etc. If you take a look at payments, you have to think about, is the right person sending the payment? Is it going to the right person at the other end? How do we authenticate, that somebody is not accessing your account who shouldn't get in there? So authenticating the person, the device, the transaction is really important. Additionally, within the data center, encryption just working everywhere all the time without me putting in a special device or a special gadget or worrying about that it's slower really would be very useful. If there was just encryption on everything, turned on all the time, in memory and at rest, and that would make me think a little bit differently about some of the products, because today I have to really look at, okay, I have to go get this add-in thing because the hardware or software that I have, they thought about security last, not first.
And I would assume that end state that you're describing doesn't make the performance flow like molasses.
That would be one of the points, yes.
So, Das, as you take a look at what these guys are describing and you look at your challenge in working to bring these types of capabilities to a broader customer base, a broader data center base, what are the things that you're most excited about?
Actually, both of the things that they brought up are actually perfect. So we actually talk a lot about the fact that ubiquitous computing is happening, and it's going to grow more and more, and the fact that we actually have people blazing a trail as the lunatic fringe. this is perfect, right? Because it used to be, we're in a hyper evolution now of technology, but it used to be that people would keep this information away from each other, and now that we're making everything scale across the globe to get these solutions to people's hands, we're just getting started. So the fact that we have this lunatic fringe that's paving a trail, starting to share what they do, starting to share what they think, that's a game changer. And then what Scott talked about in regards to how do we move forward with human security, this is also an interesting part for us. Scott, we should probably connect you with our guys that are looking at how to use biometrics like for real. But this is almost actually a computing problem too, because on Monday we had Ari from the bio team. They're doing this really cool personalized medicine where they can pull down the genome, and we gave them just this insane boost up. But you can imagine a day not too distant future, probably looking like a Minority Report, where we can actually see who you are because the computing's everywhere. We can find this information out, and it actually it sounds scary, but it takes us to another level that we can technology can evolve, and us as a human race. So technology is really fun right now because we're not just doing tech, we're actually solving like real problems. And being able to work with guys like John from Google and Scott from PayPal, it's pretty exciting times that we're in.
You know what I thought about during the biometrics discussion yesterday was I felt bad for people who were identical twins because they're going to get misprofiled all the time.
No, they're going to break into each other's systems, right? At least, well, hopefully they're friendly identical twins. So PayPal, you'll need multi-factor authentication there then.
And this could bring up like a new model for plastic surgery. I don't want to be profiled anymore, so please change something.
Which is, I just want to call out that it's important that you can't just rely on one thing.
Exactly.
You can't just rely on biometrics. There's been studies like people type different. And
right.
With high 90% accuracy, you can tell it's Scott because I type really fast and in a certain way. And by joining all these things together with all these computes, at high speeds on a chip, for instance, you can do 100 factors to identify somebody, and that's better than just a fingerprint on a phone or just a password on a system.
So, guys, thank you so much for being on today. It's a real pleasure to have you on the program. I hope you guys enjoy your time at IDF.
Thank you.
We'd love to have you back again soon.
Thanks very much.
Thanks, Allison.